we want to kind of start to express another element that pops up sometimes when we're taking the square root or dealing with some radical expressions. And to kind of illustrate the dilemma that we're going to be in, let's just look at an example here. Say I start with a 4 and I want to square it and take the square root of that. I know, just follow along with me. So 4 squared equals 16. I'm still keeping the square root because it was square root of 4 squared equals the square root of 16. And the square root of 16 is a 4. And that makes sense. I start with a 4, I square it, I undo the square, I get back to my original number. Well, let's do the same thing with a negative 4. The square root of negative 4 squared, the first step, becomes a negative, or the square root of 16. And the square root of 16 equals a 4. You know, that looks eerily similar to the one we just did before. On the second one, though, I started with a negative 4. And a negative 4 got me to a positive 4. You know, something just doesn't seem right. When you start with one number, like a 4, you expect to get a 4. You start with a negative 4, I square it, I undo the square, I'm expecting a negative 4. That's not what happened. Well, what appears to be happening here, we need to kind of keep in mind. And one way to kind of deal with this is that one of the generic rules that we're going to look at, if I'm squaring anything that's squared inside, the solution is going to be the absolute value of that expression. So my expression A is being squared, and I'm taking the square root of that. So therefore the solution is going to be the absolute value of that A. I know this is going to take a while to kind of get used to a little bit. We're not going to go heavily into it, but it is important that you understand what's happening here. So spend a couple of minutes, think this through, so you're expecting what you should be seeing as you work through a couple of these problems. Let me give you an example. That's a 6, I know, doesn't look like a 6. I had the square root of negative 6 squared. The expression of negative 6, well, as that rule that we looked at earlier, I'm going to say that that becomes the absolute value of negative 6, or 6. So again, we want to kind of keep in mind that absolute value component. Let's say, for example, I have the square root of x plus 5 squared. I know, you're not, what does x plus 5 squared mean? Well, it's going to mean something, so let's kind of figure out what we do with it. And so the expression x plus 5, the result of that is going to end up being the absolute value of x plus 5. In my last example, I had the square root of x squared plus 4x plus 4. Well, we chose that trinomial because we know that if we were to factor that trinomial, or to put it in its factored form, this is really x plus 2 times x plus 2. How cool is that, huh? So it's a perfect square trinomial of x plus 2 squared. And again, the value of that is going to be the absolute value of x plus 2. Well, as we proceed, we're going to drop the absolute value sign with the understanding that we know that it's there and that there are certain values that we have to stay away from. That kind of gets us back to some domain and range issues too. But for right now, I hope that helps as we start to build some framework here as far as where is this going to lead and what are we going to do with it.